Hello, Storlytics user. Hope you all are having a great day. Today we're going to answer one of the frequently asked questions, which is, how can you define a point of interconnection, or POI profile, for the use cases and use it for their analysis using the Defined System Module, DSM, or Battery System Modeler, BSM? Before we answer that question, I would like to mention that we are currently working with the 0.3.0 version of Storlytics, and just to refresh your memory, Defined System Module of version 0.3.0 and lower will be referred to as Battery System Modeler in the subsequent versions of Storlytics. Again, as a reminder, the DSM in Storlytics allows users to perform simulations based on their expected battery response for various battery energy storage applications. With that out of the way, let's create an Excel sheet which can be used to develop and pre-process the POI profile that can be used by the Storlytics user for designing battery energy storage system for their use case. While defining the POI profile, there are 4 different variables that need to be considered. We're going to look into that next. To explain the variables used in the POI profiles, as well as to demonstrate how any user can create a new POI profile, we're going to use Google Sheets today. But a user can use Microsoft Excel or online version of Excel Sheets to create their POI profile. As you can see, I've just uploaded the example case DSM POI profile that is provided as an example in the Storlytics software. I can now open this sample case POI profile using Google Sheets. Now let's take a look into the different variables that needs to be defined to create a POI profile that the user can use within the Defined System Module, DSM, or Battery System Modeler, BSM, to design their battery energy storage system. One of the considerations that the user has to make is that the current version of Storlytics expects the user to enter the POI profile data in a certain order and using certain headers or labels for each of the variables used. For example, the time variable should always be defined using the header sample _ time. The point of interconnection power profile should always be defined using the header P_POI, and the unit of power is always in kilowatt. The sign convention here is positive for when the battery is discharging and negative for when the battery is charging. The power factor variable at the POI is defined by using the header power _ factor and is positive for leading power factor and negative for lagging power factor. And finally, the temperature variable that defines the ambient temperature of the location where the battery energy storage system is placed is defined by using the header temp. The unit considered is degrees Celsius. The temperature considered can also be the temperature of the controlled environment where the battery modules are placed and is mostly used for degradation studies. On top of the requirements for data headers and the unit for data, the other consideration the Storlytics user should make is for the time format of the time variable. The current version of Storlytics requires that the user enter the time data in the following format: month, followed by day, followed by year, followed by hour of the day, followed by minute of the hour, and seconds of the minute. Failure to provide the time data in this required format creates an error in reading the POI profile data. The required format for the data variable is also explained in the help documentation provided in Storlytics. In this document, we can see that the data format for the time data is in month, day, year, hour, minute, and seconds. For example, the last second of 2020 would be input as 12/31, 2020, 23/59, 59. In Google Sheets, this particular time format can be achieved by going to Format, Number, and then using the Date Time format. In terms of the time resolution and the duration of time data used in the POI profile, the time resolution can be in seconds to hours, depending on the accuracy of design required. But considering the duration of the data, Storlytics can consider the data in the range of day to a year. If the data is provided for a day, Storlytics assumes the POI profile is repeated every day. If the data is provided for a month, Storlytics assumes that the data is repeated every month, and so on. In this particular example case profile, we have the data provided for a month, and Storlytics assumes that the data keeps repeating itself every month if the analysis is performed for an annual basis or a multi-year basis. With the understanding of these variables, users can now create a time series POI profile that can be provided as an input to the Storlytics software. An example POI profile can be seen on the screen. It defines a time variable in 15-minute time resolution, the POI power, the power factor, as well as the temperature variable. The final consideration to make in terms of the file format is that Storlytics currently only allows the POI profile to be input in CSV format. We can save CSV files in Google Sheets by clicking on File, Download, and comma-separated values.csv. This ensures that the POI profile created by the user is in the required format that the Storlytics software understands. One recommendation to the user is to always plot the time series of the power to ensure the POI profile that they developed is the expected power from the battery energy storage system for the use case they are considering. Here, the example POI profile we're looking at on the screen, if we plot the POI power time series, we can see that the expected response for this battery energy storage system is to charge in the early hours and discharge in the later hours of the day. Here, it is indeed the expected response from the battery energy storage system, and the users can then use this profile to further analyze the performance of battery energy storage systems that they are planning to design for this particular use case. The final thing to consider for the user is to make sure that the POI profile is saved into the Storlytics user files under Input Profile and then inside POI profiles. Once the file is saved in this particular folder, the user can then access and see the POI profile they created in the Storlytics software. Before we conclude this video, we would like to show the Storlytics user how they can use the Storlytics software to analyze the performance of their battery energy storage system that's been participating in the PJM frequency regulation market. For that, we would start by finding a typical RegD signal that PJM dispatches for battery energy storage system that's been participating in its ancillary service market. PJM's website provides us with a typical test signal, and we have downloaded the Normalized RegA and RegD signals from August 2014, and I have uploaded it to my Google Sheets. In this Google Sheet, we can see that the first column provides us the time data with 4 seconds resolution for a 24-hour period. The data provided in column B through H is for 7 days in the month of May 2014, and the values in these columns are normalized power response from the battery energy storage system. Once we have these RegD signal data from PJM, for us to use this data with Storlytics, we need to create a new spreadsheet. The first thing to do is to give the sheet a proper name. Here, I'm naming it RegD test signal. Once we do that, we can copy-paste the headers from the example DSM profile that we looked into previously to our sheet. This ensures that the proper header requirements are met for Storlytics. Once we have that, next we get the data from the PJM source file that we just downloaded. Copy the data and paste it in the new file that we have created. Once the data is passed, we need to ensure that the time is variable. Sample underscore time has the formatting required by Storlytics, which is month, date, year, followed by hour, minute, and second format. So select the entire first column and go to Format, Number, and select the date time format. Once we select the date time format, we can see that the first column is now as per Storlytics time format requirements. The only observable issue is that the default year is 1899. Let's correct that by changing the year in the first row to 2021. As the original data was in 4-second time resolution, let's apply a formula that increases the time in each row by 4 seconds. For that, we will select the first row and use the time formula that adds to a predefined time. In this case, we would add a time of 0 hour, 0 minute, and 4 seconds. This would change the time in the next row as December 30th, 2021, and 4 seconds after midnight. Select the entire first column and hit Shift-Control-D, which applies the formula to the entire column. Once completed, we can see that we now have 24-hour time series data in the format that is required by Storlytics in 4-second resolution. The other problem we have here is the normalized time series data. Storlytics requires us to provide the POI power in terms of kilowatt. So firstly, we assume in this case that our base power is 5,000 kilowatt. In order to convert this data in kilowatt, we need to first row value normalized power and multiply it by 5,000. To do it for the entire column, hit Ctrl-D. Now we have the power profile in terms of the kilowatt rating for the 24-hour time period. Copy-paste the data in the P_POI column. There you go. Now second column for the point of interconnection power profile is the actual kilowatt value. The next task is to specify the power factor and the temperature. We can assume that the power factor is a constant 1, and the temperature is assumed to be 25 degrees Celsius. The recommended next step for the user is to check whether the POI power profile looks as expected. For this, plot the power profile data. As you can, the POI profile for the RegD signal for the battery energy storage system that is participating in PJM's frequency regulation market is shown here, and maximum charge and discharge is at 5,000 kilowatt. After the profile is validated, we can save this file as a CSV file by going to File, Download, CSV. The file is now available in the Downloads folder. We would then rename this file as RegD test signal. Now copy this file and go to Documents, Storlytics User Files, Input Profiles, and POI Profiles. Paste your file here. Finally, we can open Storlytics software. In the POI profile under Define System Module, we can see that our test file is now available in the drop-down menu. Select the file and click on Calculate Energy and Power Requirement. Storlytics will then compute the max charge-discharge power and max energy charge-discharge per day. With this, the POI profile that we created using PJM's RegD signal is ready to use, and we can now start using this POI power profile to analyze the performance and possible degradation of a battery energy storage system participating in PJM's frequency regulation market. We hope Storlytics and this tutorial will help simplify your energy storage needs. Thank you and have a great day.